Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be dealing with temperature index snowmelt method, as well as the entire model building process. We're going to be building a project from scratch, downloading and importing the terrain data, delineating the watersheds, importing temperature and precipitation data, and then importing those as well, and then building our model. All right, what I have on the screen here is the website. That is the first link in the description of this video. So what we're going to do is download some initial project files, but only for the purpose of grabbing some of that data and using it for our own project. So if I scroll down to the very bottom and then scroll up a little bit, we have two links here, Truckee River and Truckee River. They're both .7z files. So I'm going to go ahead and just click on the first one and click download, and then that should download pretty quick. Okay, close that. Let's see what we got in that download. We have Truckee River, and then here we have data for an HMS project. So I'm going to go ahead and find a place on my computer for that file, and then I'll go up a level and then drag that project files over into my project directory. All right, so I'll close that. All right, those files copied over. I can now delete the zip file. Let's go ahead and open up this project. This is just going to be a project that we use data from. So let's see what we got here. Open up HMS and then File, Open, browse to that project. Okay, here's the project. Now let's open up the .hms file, click Select. It's asking me if I want to convert because we have different versions, and I said yes. All right, took a moment, but here we are. Let's open up the basin model. My goodness, there's a lot of different basin models here. I take that back. Let's go back to the website and download that other file, the second file, and then click download. I may want to reference that first project we opened, but I think the second project is the one I really want. All right, so that downloaded. Let's go ahead and open it up. I think it's also an HMS project. Okay, it just says Truckee River. That looks good. Let's go up a level and then back to our directory. Let's just add this project here. All right, that's been copied over, Truckee River. Let's go ahead and close our HMS here. I'm going to open up a new HMS so that I can open up this Truckee River project. All right, I got a new HMS open here. I'm going to go open and then browse. Here's that Truckee River project. This is the second one that we downloaded. TruckeeRiver.hms is okay. Select and then open. Okay, so that opened up fine. Let's look at our basin model. All right, this is what I was looking for. So I'm going to click on, let's see what some simulations will run. I'm going to go to Water Year 2017 as my compute simulation run and then look at some data here. We're using this basin model, Water Year 2017 copy 1, and then we're going to use Meteorologic Model MRMS corrected for Water Year 2017. One thing that I want to do while I'm here is to open up the basin model and then export the shape files, the subbasins as a shape file, which is something I'm going to need when I build my own project out. All right, so let's go to the Components tab, and then I said Water Year 2017 copy 1. What I'm going to be doing here is using this southernmost subbasin right here. It's called Upper Truckee River S10. So I'm most interested in this subbasin, but what I want to do is export all the subbasins, which is the only way to go by going GIS, Export Layers. Subbasins is what I want to select. I'll click Next. Now I need to navigate to where I want to save that. For now, I'm just going to put it on my desktop. I'm going to call it subbasins.shp and save. Okay, finish. Okay, so there it is on my desktop right there. What I'm going to do is, let's see, I'm going to close HMS. I'm going to move those shape files into a separate directory just to kind of keep them together. New folder. I'll call this subbasins shapefile. And you know what? It's probably a good time to actually create my own HMS file. That way I can keep these shape files in the GIS directory instead of just on my desktop. So I'm going to go up to HMS, open that up, and I'm going to go File, New. I'm going to call this Exercise 43, and then click on the folder icon and navigate to where I want to put this project. Okay, and select Exercise 43. I'll use US customary units and create. All right, now that that project's been created, right here, I can go into my GIS directory and then move those subbasin shapefile on into the GIS directory. So this is all I have right now. Let's go ahead and get started. Basin, I'm going to create a new basin model. I'll call it Basin 1. That looks good. A few more things that have to happen is terrain data. I'll click new and then terrain data. Now I actually need to, yeah, I'm getting ahead of myself. I need to have the terrain data file, geotiff file is what I'm going to use, but I don't have that yet. So let's go ahead and make that our first step. I went back and opened up the source project. I'll call this the source project, which is where we're grabbing some data, such as the shape file of the sub basins here. I know this is the Lake Tahoe area, but I'm not exactly sure where this sub basin is. The state boundary is also a good reference point. I'm going to go ahead and just download a shape file of state boundaries. I did a search for Census Gov shapefile Tiger. This was the first hit. I think this is the one I'm looking for here. All right, 2024. Yeah, I was looking for FTP archive link. County, I think there was one for state. There it is. So I'm going to go ahead and download state and then download this zip file. It's just less than 10 megs. It's downloading onto my desktop here, and I'm just going to go ahead and stick this into my GIS directory as well. All right, so that downloaded. Let's open it up. All right, looks like we have some shape files there. So I'm just going to go ahead and extract, extract. Okay, and then I'll just put that onto my desktop and then close that. All right, let's go ahead and load up these two shape files in our new project, and then we'll go to the USGS website, download the required TIFF files, and then get going from there. All right, here is our new basin. I'm going to go ahead and click on the basin first, so the basin model loads up into the screen here. Then I'm going to click on Map Layers, and then Add. Now I want to navigate to my GIS directory. All right, here are my project files. So I'm going to click on GIS. Now we have the state outlines and the shapefile. So let's load the shapefiles here first, the subbasin shapefile. Okay. And I need to specify the coordinate system. And I do have a projection file, so I can just click Browse and then click that .prj file for the subbasins.prj and select and then hit Set. And then the subbasins pop into place there. All right, that looks good. Let's go ahead and add the shape file now for the state boundary. So again, file, view, map layers, add. Okay, let's go up and then GIS, state boundary, and then select. Okay, so that should load into the screen pretty soon here. Hold on, I think the coordinate system was off because pretty sure this line is north and south. But we do have the state boundary between Nevada and California showing up here. One moment. I'm going to change this to UTM 10 north and hit select and then set. Oops. Okay. Oh, I refreshed the screen here. There we go. All right. There we go. Yeah, I just had to refresh the screen. UTM 10 north is what I should have put. So we know that our subbasin here is pretty much due south of the lake itself. So that's a good reference point. Now what I'm going to do is go to the USGS website, which is also linked in the description, which is right here. And now I'm going to zoom in on that South Lake Tahoe area and then grab whichever TIFF files that I think we're going to need. So here it is. Okay, so we have Lake Tahoe right here. We have California and then the Nevada side. Our sub-basin is going to be located really like down in here. So I'm going to zoom out. Here's the Truckee River, Upper Truckee River watershed. Maybe one more zoom out. Over on the left, I'm going to select Elevation Products 3 DEP. And then for the checkboxes, I'm going to select one arc second. From experience, I'm going to use historical checkbox and then uncheck all the other checkboxes. And then, yeah, the radio button will be GeoTIFF down at the bottom. I think that's good. So let's go ahead and search products and see what we get. All right, so there's a number of TIFF files here. I'm just going to go ahead and continue hovering over. So that one is going to be in the northeast quadrant of the lake. I don't want that, but I'm close. Okay, not that one. Okay, this one's probably one I want. And then that's the other one I probably want right there. So this is going to be 1 arc second, north 39, west 120. And then the other one I want is 1 arc second, north 39, west 121. I'm going to go ahead and click this download link TIFF file. That was the first one. It's downloading on my desktop now. And then I'm going to do the same thing, click download on the second panel. And then that's downloading as well. While that's downloading, I'm going to open up QGIS. That way I can confirm that these are indeed the two correct areas, and then I can also sketch a shapefile to minimize the amount of processing time it will take to do some of the GIS tasks in HMS. All right, I'm going to put these in the terrain directory in my HMS project. I could probably put them in GIS as well, but let's put them in terrain. All right, so those copied over just fine. Then I'm going to drag them into GIS. There's other ways to bring them in, but dragging them is pretty simple. All right, here are my two panels. I also want to bring in that sub-basins shapefile. So I'm going to go Layer, Add Layer. This is going to be a vector layer. Now I'm going to click the ellipse tool here and navigate to that shapefile. All right, here is my project. Here is the GIS directory. Here's my subbasins shapefile, and there's that. Okay, so I'll click Add, close this dialog box. All right, that came in just fine. Let me change the layering here. So now the subbasin is good. So here is our subbasin right here. It is true we needed both of these panels, but as you can see, we have way more area than we actually need. So I'm going to do a couple things. First, I'm going to merge these TIFF files together. And then the second process is going to be to create a mask just around this subbasin of interest, and then use that mask, that shapefile, we'll call it a subbasin plus buffer, as a way to only get the elevation data that we need. All right, first things first, let's go ahead and merge these two TIFF files together. To do that, I'm going to go up to Raster, Menu, and then Miscellaneous, and then Merge. Now I'm going to select the TIFF files that I want to merge, select all, and hit run. Okay, so that ran. I'll click close. Now we have a merged TIFF file right here. So if I hide it, this is before the merge. This right here is after the merge. That looks good. I'm going to bring the subbasin layer above that merged TIFF file. There we go. And now I'm going to zoom in and create a shape file, which is going to be subbasin plus buffer. So I'll go up to layer, add, let's see, create layer, new shapefile. All right, so I'm going to save this in my GIS directory. So let me just navigate there. Here it is. Actually, yeah, let me save it to my desktop first, and then I'll bring it into my GIS directory. So here's the desktop. I'm going to call this subbasin underscore buffer. Okay. And it is going to be a polygon. And all right, looks good. Okay. Here is my new subbasin buffer layer right here. I'm going to begin editing and then click on the add polygon. Now I'm just going to sketch out a region to define that polygon, which we'll later use for cropping. And then right click to finish that off. It's asking for an ID. I'm just going to say 1. All right, looks good. So I can bring that to the top layer if I want. Now I'm going to use this polygon shapefile I just created as a mask so that I can only bring in the elevation data to HMS that I want, not all the elevation data that I'm seeing here. This is going to be too much. Next, I'm going to go ahead and go raster and then extraction. And then I'm going to say clip raster by mask layer. Okay, so the input layer, this is going to be the TIFF file, the merged TIFF file. I can just click this down button here and then you say merged. That looks good. And then the mask layer is not going to be subbasins. It's going to be that subbasin buffer, which is right here. And then I believe I also need to specify WGS84. Okay, let me go ahead and run that. Okay, that looks good. Let me go ahead and close. So what I'm seeing here on my top layer, let me turn all the other layers off, is right here. It's just no data and spots. And then the rest of the area that I want is the topographic elevation data for the subbasin outline plus a buffer. So this is great. This is what I want to export from QGIS and ultimately bring into my HMS file as my terrain data layer and then link that to my basin. All right, so I'm going to go ahead and right click, export, save as. This will be a GeoTIFF. I'm going to go ahead and navigate to that GIS directory one last time, our terrain directory. Yeah, this is exactly where I want it to be. So I'm going to call this USGS merged cropped and then save. Okay. All right, we can go ahead and save QGIS and leave that behind. I'm going to bring up my HMS project, and now we can go Components, Terrain Data Manager, New, call it Terrain 1. That's fine. It's the only terrain we have. Okay, here's the terrain directory, USGS merged cropped. I'll click Select to that and Finish. So I'll close that. With our terrain layer here, now I'm going to click on the basin model and then under terrain data, select terrain 1 and then click save. I think that came in here. Let me just change the layers here. Here's the terrain layer. All right, looks good. So this is all I need. I don't need the state boundary outline shape file anymore. This is going to be good. All right, now we can go ahead and use some of those GIS tools up here in the menu. We have the coordinate system and terrain reconditioning is sometimes required, but not always. Now I'm going to click pre-processing sinks. And what that does is it's adding in the sync fill and sync locations layer. That's good. The next task usually takes the longest. So I'm going to go GIS, pre-process drainage. Since this step takes the longest, this was the primary reason for me to apply that crop around the giant TIFF file. So we only brought in the data that we needed to be doing the pre-processing for. All right, so that was great. That was only like 10 seconds. It gave me a flow accumulation layer, a flow direction layer. The next step is to go to identify streams. I've had best luck just using 3 miles squared. Okay, so we have a stream right there. I'm going to turn on the subbasins layer though. All right. Now let's see what I need to do next. Breakpoint manager. Okay, so I need to create a breakpoint and it needs to be on this stream right here. So I'm going to go ahead and zoom in on the subbasin layer and where that stream intersects the subbasin boundary. So maybe just like one cell up is where I'll put my breakpoint. So I'll click the breakpoint tool right here, and then I'll click on the identified streams layer. Okay, breakpoint 1, that's fine. We'll call it that. And now we're ready to use the delineate tool. So this is the main watershed delineation tool. Subbasin, I'll just call this subbasin underscore reach underscore yes, insert junctions, and then the junction prefix, I'll just call it junction underscore, and then I will convert the breakpoint to a sync and click delineate. All right, excellent. So what we have is our subbasins. I want to toggle off this subbasins SHP, and if I turn that off, okay, that looks better. Next, what I want to do is confirm that this is the same subbasin as the original model, which is right here, and whether or not it looks the same. And one way I can do that is just to confirm the area, and I should also merge those individual subbasins. But here's the original subbasin I'm trying to match. I have an area of 54.0 miles squared. So if I go to my project, let's see, I'm going to have to merge these. So one second, I'll just click and then hold down control, continue clicking. Okay, let me see if I can merge those ones. GIS merge elements. Okay, that worked. Now let's click on that one we just merged, and then the next few downstream. Okay, GIS merge elements. All right, just a few more here. I'm holding down the control key as I single left click on these subbasins to select them, and this should be the last one, merge elements. All right, so if I click on my one and only subbasin now, I can check out the properties. It says 53.965. So that's pretty darn close to 54.0. So I'm happy with the watershed delineation. And it's also geo-referenced, of course. You see the latitude, longitude data, as well as some of my default parameters for a subbasin. Next, I'm going to specify some of the subbasin properties that I can already. And this is based on the source project. So some of the data from these tabs I've gone ahead and collected ahead of time. And so what we're going to do here is specify the discretization method is going to be structured. And then I'm going to click on discretization, SHG 2000. That looks good. I'm going to save it. And then while I'm here, I'm going to go GIS, compute, grid cells, so we can actually see the cells. Now they've been computed, but I'm not displaying them yet. So I'm going to go to view, map layers, and then discretization. All right, that looks good. So I can see the actual cells now in my structured discretization. Back to the subbasin tab. The next is canopy method. So I'm going to use simple canopy. And then for the canopy tab, which appeared right here, I'm going to say 0 is my initial storage percentage. Crop coefficient is 1.0. Max storage is also 0. Only dry periods. And then the uptake method will be simple. Okay, so save that. Back to the subbasin tab. The snow method I'm going to use is going to be gridded temperature index. And then the snow tab here has a lot of data. So let me try to make room for that. I'm going to keep these first few values as default value and then scroll down a little bit. Then I'm going to go for my PX temperature will be 34.5. Base temperature 34.5. ATI coefficient is 0.98. Wet melt method is going to be constant value, and then that wet melt rate will be 0.1. The rain rate limit is going to be 0.1 as well. Dry melt method is ATI function, so keep that as it is. The ATI melt rate is a paired data set, which I have not defined, so I'm going to go ahead and do that next after I finish these last few fields. The cold limit is going to be 0.2 inches per day. The ATI cold rate function, something else, another paired data set that I need to define. And then the cold rate coefficient, 0.35. Water capacity is 3%. And then ground melt method will be fixed at 0 inches per day. I'm going to go ahead and click Save to that. All right, for these two paired data sets, so I'm going to go up to Components, Paired Data Manager. What I want to select is the ATI melt rate functions, new, and then I'll give it a name. I'm just going to call this melt rate. Obviously, if I had more than one melt rate, I would give it a more unique name, but that's fine. The other one I want to define before actually giving the values is the cold rate. So ATI cold rate functions, new, and then I'll just call this cold rate. All right, so what that resulted in is up here in my Watershed Explorer, I have a paired data directory here with my melt rate and cold rate data sets. Let's define the melt rate first. That's this one here. So it's going to be manual entry. The units will be degree Fahrenheit, inches per degree Fahrenheit day. All right, and then the table values right here, I'm just going to copy in the same values as the source project had it. Okay, so that is the table of data. The other one we need to define is the cold rate. So I'm just going to confirm the data source is manual entry. I'll be putting it in just a moment. And then the units are correct. All right, so here is the table data for our cold rate and save. Now we can go back to our data, our subbasin, and I was on the snow tab. And now if I scroll down here to the ATI melt rate function, I can just click melt rate, and then the ATI cold rate function, I can click cold rate. All right, go ahead and click save. All right, let's go ahead and go back to our main subbasin tab here. I'm just going to go ahead and finish this off, and then we can go to the individual tabs. So what we're doing next is the loss method will be deficit and constant. That's this one up here at the top. The transform method is going to be mod Clark, and then the base flow method is going to be linear reservoir. All right, so let's go ahead and take care of those. The loss tab is right here. For the initial deficit, we're going to say 2.08. Maximum deficit is going to be 8.31, and then the constant infiltration rate will be 0.39, and that's in inches per hour. Percent impervious is 2.5. All right, I'm going to save that. And then the transform method, we have a transform tab right here. The parameters are going to be standard method. Time of concentration is 11.54, and then the storage coefficient is 17.31. The base flow tab is next. We're using linear reservoir here. We're going to be using 2 layers, so I'll change this to a 2. The initial type is going to be discharge per area. Layer 1, initial, we're going to use 0 CFS per mile squared. That fraction is going to be 0.3. The coefficient is going to be 294. The number of reservoirs is 1, so we'll leave that there. Okay, down to the second layer here, I'm going to define the values as 1.50 for the CFS per mile squared. The fraction is also going to be 0.3, and then the coefficient now is going to be a higher number. That's typical of lower layers, 577, and we're going to use 1 reservoir. So I'll go ahead and click Save. The last tab here is the Options tab. What I want to do is have a observed snow water equivalent time series data set. Now I don't have that data yet, but I can go ahead and get it. Let's go ahead and create it first, and then we'll get the source data from the source project. I'm going to go up to Components, Time Series Data Manager, Snow Water Equivalent Gauges, New. Okay, so I'll just call this Observed Snow Water Equivalent Data, something like that, and create. Okay, so now I can select that data source right now, but I'm not going to because I prefer to sign the data first. So here in the time series data folder, I can click on observed snow water equivalent. And now I need to go ahead and get that data. So I'm in my project directory. Here is exercise 43. Here's data. What I want to do here is create a DSS file to use as a container for all my DSS paths. So I'm going to open up DSS view, file, new, version 6. and then navigate to that data directory. Data directory is right here. Okay, I'll just call it data.dss. All right, so I have my file created right here. Now what I want to do is find the snow water equivalent observed data from the source file for that subbasin. So I'm going to go back to, this is the new project we're creating. Here's the source project right here. I'm going to click on the subbasin, and then I'm going to come over here to the options tab, sort of backtrack from where we were working. That file for observed snow water equivalent time series data is called Upper Truckee River underscore S10. So what I'm going to do in the Watershed Explorer is go to the time series data, snow water equivalent gauges right here, and then find that Upper Truckee River right here. And now here is the file, and then here is the path that I want to copy into my own data.dss file, which I just created, stored in that data directory. So the project is Truckee River, and then data snotus output.dss. Let me just go ahead and open up that file first. So Control O. This is the source project right here, Truckee River, and then data, and then it was Snotus output. So we have the DSS file and all the paths on the screen now. We need to find the correct snow water equivalent time series. So I'm going to go back to DSS view, and then this is the one I'm looking for. Snotus, 1 day, looking for something fairly unique. This part B of Upper Truckee River, I think is fairly unique. So let's use that as a filter. I'm going to go to part B here, and then Upper Truckee River. Cool. All right, perfect. So this is the one right here. So this would be a time series data set. Let me go ahead and just peek at the data itself. Okay, that looks good. So I'm going to go edit and then copy to. Now I'm going to navigate to the new project we just created, specifically that DSS file that we have open. I'm going to go up, and then exercise 43, data, and then this file right here. All right. Now let's just refresh to make sure that that copied over. And boom, there it is. Perfect. Now we can reference this DSS file and this path in our options tab of the subbasin of the new project. All right, I think I said that right. So here's the subbasin. We have our snow water equivalent gauge ready to go. That looks good. So I'm going to click DSS record and then navigate to that data file. Here's the data directory. Here's the data.dss file. That looks good. Now let's click on this button to select the path. It's the only path in here. That makes it easy. Set path name, and we are good. So I'm going to click save to that. Now I'm going to go back to my subbasin options tab and have some confidence by selecting observed snow water equivalent time series dataset, knowing that data really does exist there, and then click save. Next thing I want to do is create a control specification. So I'm going to go up to components, control specification manager, new, control 1 is fine. So control specification, I'll click that. Now I'm going to type in the start and date time of our simulation. So that's going to be October 1st, and that's going to be 2016, 100 hours. And then it's going to end at the end of the year. So we're just going to do a 3-month simulation on a 1 hour time step. Let's go 31 December, also at 100 hours. The time step will be 1 hour. We can click save. So that's one of the main components to the simulation run. We're going to come up here, create a simulation run that requires the basin model, the MET model, and the control specifications. So we have a basin model ready to go, and we have our control specification. What we need next is our meteorologic model. So to do that, I'll go up to components, meteorologic model manager, new. I'll just leave it at MET1. That's fine. It'll be our only meteorologic model. So I'll select meteorologic model 1, and now we need to specify these parameters here. What we're going to select for this project is a gridded precipitation method, a gridded temperature method, as well as an evapotranspiration called gridded Hammond. Also, I want to select the set to default values for replace missing. All right, US customary, that all looks good. Next, what we need to do is gather the precipitation data and the temperature data. So up here in the Watershed Explorer, you notice that some icons appeared underneath my meteorologic model once I specified the method. So for gridded precipitation, I need a precipitation grid. For gridded temperature, I need a temperature grid. And then gridded Hammond just uses this coefficient and then data from those other two grids. To download the precipitation and temperature data, we're going to visit this web page here. Says downloading MRMS precipitation data, but it can be used for temperature as well. I will leave a link to this page in the description of this video. All right, what this page does, this is another tutorials and guides from HMS. And if you scroll down just a little bit, there should be a link to download the data retrieval scripts using Python right here. So downloading the data retrieval scripts, you can go to the GitHub page or just click on this data retrieval scripts.zip, and then that will download a zip file that contains Python scripts to download files. More information about this process I'm going to speed through is in my HMS exercise 26 titled Downloading and Importing MRS Gridded Data. All right, let's go ahead and see what we have in this zip file. Like I said, it's a number of Python scripts, and the ones I want are going to be this one, retrieve QPE. I'm just going to bring that out to my desktop, and the other one is just below it, retrieve RTMA temperature. All right, so I'm going to close that. Then this zip file, I'm going to delete that. Here are my two scripts. What I'm going to do is I'm going to put them into my project directory. I'm going to create a new folder here called scripts. So new folder and scripts. I'll open that up and then I'll just drag them in. Now what I'm going to do is open up VS Code to this directory, this folder here, and then open up these files, make a few modifications to download the data I want, and then run them. All right, so I have my files over here on the side. Let's go with precipitation first. Retrieve QPE, gauge correction. And here it is. So what I'm seeing here is a script. It has a start and end date time and a step of 1 hour. So we're going to have to modify that as well as the destination. But just to look ahead to see what this script is doing, it's going to this iowastate.edu webpage. So I'm going to go ahead and just take a quick peek. MRMS NCEP gauge correction. Okay, so I opened up a new tab. It's yearly data. I believe this is for the continental United States. So if I scroll down to say 2016, and then I select the month like October, and then let's just click the first day. All right, MRMS NCEP. So this is precipitation. And then the first link here is gauge correction. So this is all for October 1st of 2016. Now here are the hourly data files. They are zipped up GRIB files. So I could click on them and download them one at a time. There's 1 hour. There's another hour. Now, if I wanted to download hourly data for a 3-month time period, that's going to take too long, and that's the whole point of writing a script. So I'm going to go ahead and delete those. Let's go back to our VS Code, and let's go ahead and type in the date time that we want to start. That's going to be October 1st, 2016. And we're going to go through the end of the year. So I'll just say January 1 of 2017. All right, I'm going to leave this line 9 as it is for a 1 hour time step. Also, I'm going to leave really everything else as is except for this destination right here. I want to create a location to copy all these files to. So for convenience sake, I'm just going to create a new folder on my desktop and I'll call it precipitation data. Okay, that looks good. I'm going to right click and then copy as path. Now I'm going to come over here to line 15 and then paste that in and then click save. All right, I think I'm ready to go. I'm not going to look at the script or dissect it too much. I'm just going to trust that it works, and let's give it a shot and then see if it did. So I'm running the Python command right now and just hit enter. You need to have Python installed on your computer for this to work, as well as the Python environment variable. So here we go. We're downloading the files 15, 16, 17. So that's 1 day of data right now. We're up to 43, 44, 47. So that's 2 days. I'm going to go ahead and let that run. Now I'm going to move over to the temperature data and start downloading that. First things first, let's go ahead and create a separate directory on the desktop for now. Ultimately, once these files are downloaded, I'll move them into the project directory before actually importing them. All right, so I'm going to go new folder, temperature data, and back to VS Code. Here is the temperature script. And what I'm going to do is just basically copy what I had before for the same date time. Here we go. So I'll highlight those and then paste. So that's the same final 3 months of 2016. And then we need to update the destination. So I'll right click and then copy as path. And then I'll paste. And I could change the slashes, or it's just easier to put an R right there and save. All right, I think that's all I have to do. Right now, unfortunately, this terminal is running the precipitation script, so it's occupied, but I can just as easily run this temperature script just in a command prompt from my computer. I'm going to open up a text file here just to print out that command prompt. So there's going to be two arguments. The first one is the Python executable path, and then the second would be the path to the script itself. All right, let's go ahead and find the location to my Python on my computer. So I'm going to go C drive, users, my user account, and then it's going to be an app data. And then after that, local, and then programs. Okay, and then Python. And I have Python version 3.13 installed. Right here is the executable. So I'm going to go right click and then copy as path. Let me go back to my text editor here, and that'll be the first argument. So I'm just sort of preparing the command right now, and then a space, and then I need a absolute path to that temperature script, which I have saved in my scripts directory, which is right here. So I'm going to right click, copy that, okay, and then I'll paste that in there. Okay, that looks good. So let's go ahead and open up a command prompt. Just go ahead and click on the Windows icon and then type in CMD, should work, yeah, command prompt. So click on that. It opens up a command prompt. Now I'm going to copy my command, Control C, and then to paste it here, you would just right click and then hit enter. And it's opening the files and it's downloading them right now. So let's go ahead and open up the folder just to confirm that. All right, so these are now my temperature gridded data sets, 1 hour at a time for the final 3 months of 2016 getting downloaded. This is going to be a fairly lengthy process. So right now we're at 20, so just finishing up the first day. So it may take a while to let these run. You just have to be patient. All right, I got all that data downloaded now. Here we have the precipitation data, and it is right here. And it is not in the GRIB format. It is in a zipped GRIB format. So what I want to do is select all the records, Control A, and then I'm going to right click. And I know there's an extract all here, but what's worked best for me is going down to show more options. And I have 7-zip installed as an unzipping utility here in Windows. So I just hover over 7-zip and then extract here. And then I wait for this progress bar to complete. All right, that completed. So now I have twice as many records. What it was about 2,200, now it's about 4,400. What I want to do is just remove the zipped files so I don't get confused. That's up here. So I'm just going to go ahead and select the first one, shift, and then page down, and then wait until it's at the bottom or halfway down. All right, there we go. So this is the bottom of the zip files. Delete. All right, so we have our values for precipitation in GRIB format ready for use in the importer tool. Over in the temperature data, we have all of our GRIB files already here. There are a couple index files for each file. That's why there's about 6,500 files. There are a few missing hours, and that's all right. We're going to set our simulation to just set to default, but we're good to go. There's no unzipping required for this temperature data for whatever reason. Not complaining. Okay, what I want to do next is move all these files into the project's data directory, which is right here. We have our data.dss file over here already. And then here are the precipitation and temperature data. The next step is to bring these time series data sets, these gridded data sets, into the DSS file. And we're going to accomplish that using the importer tool in HEC HMS. So I'm going to open HMS, go File, Import, Gridded Data, Importer. Now, the first step in this wizard is to identify the source data. That's going to be, we'll start with precipitation. So click on the folder icon. And then here is the project directory. Here's data. And then here is precipitation. Okay, it's opening right now. Here are all the records, some 2,200 or so. I'm going to Control A to select them all, and then click Open. All right, and then click Next. And this takes a while. Now I want to select my QPE data, the precipitation. I'll just move that over and then click Next. And on this screen, what I'm going to use is the clipping source. We don't need the entire United States. We just need that sub-basin plus buffer shapefile region. So I'll go ahead and navigate to that shapefile in the GIS directory. Here's the project data. Here's the GIS directory. And then I want to say subbasin buffer shapefile. There it is. Okay. This is going to use the SHG projection on a 2000 meter cell size. And next. All right, last step here is to specify the outlet location. That's going to be that data.dss file. Here is the project, here is the data directory, and then here's the data.dss file. Open. Now it gives me this warning about overwriting, and I want to say yes. I'm not going to actually be overwriting though, because this part C is going to be called precipitation, and the only record in there currently is for that snow water equivalent time series data. What I am going to do is in this part F, type in MRMS. This is typical to list the source of the data in this part F, I've noticed. And let's go ahead and click next and see what happens. Okay, now we have a progress bar. Wait for. Now if I open up that data.dss file and then refresh the screen, I see that I now have a bunch of precipitation data. And it looks like, yep, it starts on October 1st. It's hourly data. Fantastic. All right, let's just go ahead and highlight a few records and then scroll through them just to make sure it looks correct. So here's the first couple days of data. I'm just going to see if we have any precipitation by scrolling through. Okay, looks like there's a little bit of precipitation at the very end here, right about day 2. And then just taking a quick peek at the metadata here, we have a 13 by 16, and that should be similar to our total grid extents. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, maybe it gets a couple extra in each direction. That's fine. All right, that looks successful to me. Let's go ahead and perform the same import process, this time with the temperature data. All right, so I'm back in HMS. I'm going to go click on File, Import, and then the Importer tool. All right, so let's navigate to the temperature data now. Here's the data directory and now temperature data. We should see a bunch of grid files. Here they are. I'm going to Control A to select them all and then open. All right, now I'll click Next. All right, that step completed. So now I'm going to click on the temperature variable, move it over to the right panel, and then click Next. Again, on this step, we're going to use that shapefile to clip out just the area we want, and it's right here. Open. The projection, again, will be SHG, and the cell size will be 2000. And Next. Now let's go ahead and define that. Click on the data.dss file. That's good. It's asking if we want to overwrite. The answer is yes, because we want to add or append data. Again, I'm going to go MRMS, and then our part C should say temperature this time. So we'll click next to that. Okay, that process completed. Let's go ahead and check out the DSS file now. So it's we need to refresh to confirm we have temperature data. I'm going to go to View, Refresh Catalog. And boom, here is our temperature. So now if I look at the part C filter, I have precipitation, snow water equivalent, and temperature. All right, just for kicks, let's go ahead and look at some of that temperature data. All right, so here it is. This gridded temperature data is a time series of grids, if you will. So that looks good. We can go and hover, confirm. Here's the grid info. This is in degrees Celsius. Let's close that. Minimize DSS view. Let's go back to our HMS model. Now that we have those paths, all that data, we can finally go back and link it to our model. So here for precipitation grid, I'm going to go ahead and file name, single record DSS, and then select that DSS file. It's project, data, data.dss, and select. And then for the path here, I'm going to click this button. Then it opens up all the paths in that DSS file. What am I working with? Precipitation here? Yep. Okay, so part C, I just want to filter by precipitation to make sure. Click the first record and set path name. All right, I'm going to save that. Do the same thing with the temperature grid set now. So I'll have that selected, single DSS file. Go ahead and click the folder icon, click the DSS file, and now click this button to list out the paths. I'm going to filter by temperature. There we go. And set path name. All right, that looks good. Now that these grids are defined and have data, we now need to reference them in the meteorologic model. So let me scroll up to the MET model, which is right here. Here is the gridded precipitation. And now that we have a grid here with data, I feel confident making that selection of precipitation grid. Same thing with temperature. We need to know the temperature so we know if the precipitation is rain or snow. Of course, that depends on the other properties, such as those threshold temperatures. And that looks good. All right, and save. I think the next thing we need to do is create a simulation and run it. Let's go ahead and try that. And if we get errors, we'll go back and fix. All right, so I'm going to go up to the compute menu, simulation run manager, call it new run. It can be called run one. It's the only run and the only basin, the only meteorologic model, and the control specification. All right, so looks good. All right, I've changed the map display a little bit here and just checked a few things. What I want to do is go ahead and select that run one simulation from our compute menu and then click compute. And now that's running and it looks like it's successful. So that's awesome. Let's go ahead and look at some results now. I'm going to go right click, view, and then graph. This is the release or discharge from the subbasin here on the bottom plot for the last 3 months of 2016. And then the top plot here is a hyetograph showing the rainfall depth. All right, one thing I want to look at is the snow water equivalent because I have a snow water equivalent observed time series right here. So I could see how the snow piling up in the computed results compares to what is observed, which is quote our target snow water equivalent for this simulation. I'm going to go to the results tab right here and then expand the simulation run. Here's run one. And then for the subbasin, I want to select observed snow water equivalent and then hold down control and then snow water equivalent. All right, so here is a preview of the plot. But if I click the plot graph here, I can see it a little bit better. I modified the colors a little bit. And of course, this is just the first 3 months of the water year. So full water year would show more. But we see like mid-November, we get a storm and then that begins the snow water equivalent increase. Computed is blue, and then red color is the observed data. So if I was to calibrate this model and modify some of the snow-related parameter values, I would probably modify it in such a way that more snow or more snow water equivalent is in my subbasin. So I'm going to go ahead and just make a couple of changes and then see how the results compare after that change. What I can tell from this plot is that our observed snow water equivalent is above the computed. So we need to change the snow parameter values in such a way to produce more snow in our subbasin for this last few months here, this last month and a half. The first half of the simulation looks great. Let's go back to our subbasin. So I'll click on that and then I'll click on the snow tab. And what we could do is just change the temperatures a few degrees. Let's see what happens if we do that. And then we'll save and rerun the simulation. So I'm going to change it to just 37 degrees as the temperature. This is a threshold related temperature as to when the precipitation decides to be rain versus snow. Just one of many different parameters we can mess around with. All right, after running this one more time, let's go back to that results tab and then see what we got here. So the observed snow water equivalent should always be the same. That's not changing. And then I'm going to also click on snow water equivalent here. All right. From the preview, it looks like a much better fit. Let's go ahead and click on that plot. And I changed the colors to see a little better. And this looks a little better in some ways. It looks like we've minimized the maximum error. We certainly have more errors here in the first half of the simulation, but then less total error, I would say, because we underestimate for a couple weeks here and then we overestimate a few weeks later. Certainly, changing those temperatures wasn't the only change we need to make to better calibrate our snow water equivalent using this temperature index snowmelt method. But I'm going to go ahead and just say that's it. This exercise has been going on long enough. We did all sorts of things. We built the model from scratch by bringing in the terrain data and then also downloading the precipitation and temperature data, setting up the model, and then all the components, running the simulation, and then looking at some results.